So good morning, everyone. I'm a student at UBC as well as an architect who's been practicing for many years. Working with BC Housing, my research focuses on the relationship between climate change impacts and multi-unit residential buildings. So as you may know, buildings and construction are responsible for a high percentage of greenhouse gas emissions, about 40% globally. And buildings and their occupants are also highly vulnerable to the impacts of climate change, whether they relate to floods, hurricanes, wildfires, or extreme heat. Next slide. Next slide. My research looks at the two sides of the climate change impact coin, mitigation and adaptation and resilience. Mitigation and green building has been around for many decades and has been formalized through many frameworks such as the LEED rating system. The building you see in this image is a LEED Platinum building that I worked on several years ago at the Rochester Institute for Technology. Next slide. Adaptation and resilience is a more recent phenomenon in the building industry, but it has been growing quickly due to the frequency and intensity of extreme weather events and slower onset changes such as more intense heat. This Brooklyn, New York waterfront building is a recent example of flood adaptation strategies. An elevated ground floor with flood resilient materials, mechanical equipment on the roof instead of in the basement, and a large emergency generator for backup power. Next slide. However, adaptation and resilience has generally evolved separately from mitigation and green building. So my research develops a framework to integrate these two paradigms. Why is this important? Because strategies for one could have unintended consequences for the other. For example, on the mitigation end, there has been a strong push to electrify building heating, which may increase risk should there be power outages. Similarly, increased hardening of buildings to resist against tornadoes or storm surges could significantly increase embodied carbon emissions. So my framework helps project teams to identify where mitigation and adaptation strategies may conflict and enables a more integrated design process where team members can better work together to set goals and identify solutions that are more synergistic. Next slide. The result is the Integrated Building Adaptation and Mitigation Assessment, known as IBAMA. IBAMA enables teams to propose strategies for mitigation and adaptation and determine approaches that are synergistic, which you see in green, conflicting, which you see in red, or that may have some trade-offs to be evaluated. The assessment helps to evaluate both mitigation and adaptation with respect to proposed strategies, but other key project priorities such as technical requirements and costs. Our aspiration is that the framework changes the way that BC Housing and other industry stakeholders incorporate climate mitigation and adaptation, resulting in better solutions overall.